Welcome to the third lecture of this lab course. In the previous lecture we discussed about the Boxford machine tool, its components and control panel. All the keys that lying on the control panel is been briefly discussed in the previous video. In this video lecture we will discuss about the GNM codes. We will also discuss about the common format of the blocks or instructions which include these codes. Then we will discuss about the different available NC part programming techniques, and in those techniques we will focus on the manual part programming, installation of the Boxford CAD/CAM simulator. The video for the installation has already been uploaded, so you can watch the video and you can install this simulator, which we will use in the coming lab practicals. We will also write a program for the drilling operation using GNM codes. The title of the lab practical is Introduction to Part Programming Using GNM Codes and Installation of the Boxford CAD/CAM Simulator. Objectives include to know basic GNM codes and its function used for various purposes in CNC machine, to know how to install Boxford CAD/CAM Simulator, and to write a program for drilling operation. Machine tool used in the description of that machine tool. So the same description also been provided in the previous video lecture. NC part programming methods. So we have different methods available which are usually used for part programming. Numeric control part programming. Part programming can be accomplished using a variety of the procedure ranging from highly manual to highly automated methods, which includes manual part programming method, computer assisted part programming method, CAD/CAM part programming, manual data input. Manual data input. So the description is given. The NC part program is entered directly into MCU unit at the site of the processing equipment. The use of the punch tape is avoided. The programming procedure is simplified to permit machine operators rather than part programmer to do the programming. Second is computer assisted part programming. The programmer prepares the set of the programming instruction or processing instruction in the high level language. For complex parts, the computer language is much easier to use than the low level coding required in the manual part programming. So nowadays we model a figure and then we import the model into another software to generate the codes, and then we send those codes to for the simulation, and after simulation, if it is valid or if it is okay, then we send those codes to the machine tool or processing equipment for manufacturing purposes. CAD/CAM part programming, an advanced form of computer assisted part programming in which an interactive graphic system equipped with the NC programming software is used to facilitate the part programming task. The term CAD/CAM means computer aided design and computer aided manufacturing. In this method, the programmer works on the CAD/CAM workstation to enter the machining commands. The actions indicated by the commands are displayed on the graphic monitor, which provide visual feedback to the programmer. Also, certain portion of the programming cycle are automated by the NC programming to reduce time. The software which are usually used include MasterCAM, StipNC, and so on. Manual part programming, which we will focus on this lab course. In manual part programming, the part programmer prepare the NC codes using low level languages. The codes are alphanumeric instructions, which is understood by MCU or machine control unit. It consists of numerical values and alphabetical characters and other symbols. It consists of blocks or lines having words consist of GNM codes. A word specify about the operation, axis position, feed rate, spindle speed, tool number, and relative motion between the cutting tool and the workpiece. So one word consists of alphabetical characters as well as numeric values. A block is one complete NC instruction. Organization of the word within the block is also very much important, which is called block format. So here what is G code and what is M code, the definition is mentioned, the description is given. G codes, also called preparatory codes, are any word in the CNC program that begins with the letter G. Generally it is a code telling the machine tool which type of action to perform. Similarly, miscellaneous codes are M codes, which control CNC program ending, spindle motion, tool changing, and fluid on off or coolant on off, and to rewind the program, etc. This is the common format which is usually followed while writing NC instructions or blocks. So these are the words. N50, N basically shows the sequence number, G shows the preparatory function. Similarly, X, Y, Z, these are the dimension functions or dimension words, which basically define the axis and the particular location in that particular axis. F shows the feed rate or feed motion or feed function. S shows the spindle function. T shows the tool function. M basically shows the miscellaneous function. So it is called G and M codes, but it is not limited to only G character or M character. It also include N, X, F, S, etc. Programming key letters. So these are the key letters which are usually used in the G and M language, and the description is also been provided in the slide. You can read it by yourself. Coding for manual mode programming. So in chapter number 7 in the recommended book, you can find these appendices or tables which are 7a, 7a.1, 7a.2 or 7a.3, where G and M codes are being mentioned with comments or descriptions. Some of the important codes are mentioned in this slide. You can see which include G92, G21, G01, G02, G03, G00. Coding for manual part programming. These are again some of the codes. So the basic code should be remembered, which are repetitively used in the part program. This is one of the sample program which is related to drilling operation, in which we have to drill 3 holes at different location on the prismatic workpiece. The statement, you can read the statement. I will summarize the statement. So in the statement, we are basically performing drilling operation and at 3 different locations. The part is gripped in the place so that its top surface is 40 mm above the surface of the machine tool table to provide ample clearance beneath the part for hole drilling. So clearance is very much important to avoid the touching of the drill bit with the machine tool, or machine vise or work table. The X, Y, Z axes are defined as shown in the figure. So in figure, coming slide, you can see here in this figure 3 different holes at different location is being mentioned. Back to the statement. A 7 mm diameter tool drill bit is used. The feed rate is being mentioned, that is 0.05 mm per revolution. Also the spindle speed is also mentioned, that is 1000 rpm. At the beginning of the job, the drill bit or drill point will be positioned at the target point, and the coordinate of that target point is mentioned, that is x is equal to 0, y is equal to -50, and z is equal to +10. And the axis system or unit system is also mentioned, that is in millimeter. The last sentence tells us about the location of the tool, which is at target location, and the coordinates of the target location is also mentioned. So we start writing program for this statement, in which we have to drill 3 holes at different location. The coordinates of the location is mentioned. Here you can see this figure. This is hole number 1, hole number 2, hole number 3. This is the program which is being written for the drilling operation or as per the problem statement. So at one side you can see NC part program code, while on the right side the comments are mentioned. It is very important to write the comments so that you can, for example, if you want to read the program after 10 days, after 2 weeks or 3 weeks, so from the comments you can easily identify the information regarding that particular instruction or block. So N001, G21, G90, G92, you can see the appendices or tables for the description of those codes. For example, N001 shows the sequence number 1 or the instruction number 1. G21 is used for the G90 is used for the absolute coordinate system. G90 is used for the absolute coordinate system, and G92 is used to define the origin. And after G92 you have to define the origin. For example, it is being mentioned in the statement x is equal to 0, y is equal to -50, and z is equal to 10. And after completing the block you have to use the semicolon. In the second NC instruction we use G00, which is used for the point to point rapid traverse, because we are interested in the location, not in the path. So we can swiftly move the cutting tool from the origin position to the position where we want to drill the hole. And then you have to mention the coordinates where you want to shift your drill bit or cutting tool for drilling the hole number 1. In the third NC instruction, N003, G01 is used for the linear interpolation, because now you have to move the drill bit in the linear direction, linearly in the downward direction or in the negative z direction. G95 shows mm per revolution, because here you have to mention the feed rate as well as the spindle speed. Z -15, it is basically shows the depth of the drill bit or drilled hole. F 0.05 shows it from the statement. You can see the feed rate, or you can note the feed rate, that was 0.05 mm per revolution. Spindle speed is also been mentioned, that is 1000 rpm. M03 is the code which is used to turn on or to start the rotation of the spindle in the clockwise direction. It is very important to note that the MC unit first read the whole or the processing equipment first read the whole statement or the whole NC instruction, and after that it takes the action. Word by word action is not being taken. It is defined by the language that after reading the whole instruction, the machine or the processing equipment should take action. Similarly, N004, it is the fourth sequence or fourth instruction, where you have to retract back the tool to the surface, and then again you have to move your tool to the second location, that is Y60. X is already been mentioned. Y is you have to move the tool to the in the Y direction, and then you have to follow the same sequence for drilling second hole, third hole. In the second last sequence, or in the second last NC instruction, you can see G00 X0 Y -50. So it is used to shift back the cutting tool to the origin position from where you have started, and then you have to use M05. Similarly, N012 or sequence number 12 or NC instruction number 12, is only being mentioned with the M code, that is M30. So M30 shows that to end the program and to rewind. This program is being written for the mass production. If you want to use the program for single part, then you can use the code M02. M05 is used to stop the spindle, right, which has been mentioned in the second last instruction. So this is the simple program which is being drafted by the programmer to drill 3 holes at different location on the prismatic workpiece. Reading and practice assignment number 1. Practice, understand and write an NC program code for 2-axis profile milling. You need to follow the example A7 A.2 that is related to 2-axis milling, and the reference book has been mentioned. The book chapter along with pages is also been mentioned in this slide. So this was all about this lecture. If you have any question, you can discuss in the comments or in the